Okay, guys, this one will be quick. I did not realize there was another example on the next page. So this video will just be on this example. So looking at example 6, we need to multiply by the reciprocal. Well, what happens when we don't have a fraction here? Remember, we can just put that under 1. So if we multiply by the reciprocal, that would be the same as saying 6x squared plus x minus 15. So we're just rewriting the first one as is. But then we're going to multiply, and then remember, keep, change, flip. So flip that one. So 1 over 3x squared plus 5x. All right, and now we're going to factor. So just like we've been doing in all the other ones, we are going to factor. So this one we need to factor by grouping. We need to think about two numbers that when you multiply them, you get whatever 6 times 15 is. Let me do that calculation real quick. All right, so I'm going to do that up here. So whenever, okay, here we go. So we need two numbers that when you multiply them, you get negative 90. And where did I get that from? Remember, if you have an a value, you have to multiply those two together. So negative 90, but when you add them, you get positive 1. So we need two numbers that are basically right next to each other. So maybe you thought about 9 and 10. So remember, because that is positive, that means your bigger number is positive, which means our smaller number is negative. All right, so the way that this works then, if you remember factor by grouping, you could skip through this part, but if you don't, if this is something you have been struggling with, then don't skip through this part. So basically what we're doing is we're splitting that positive, so this was, say, 6x squared plus x minus 15. So we're taking this positive x and we're splitting it between 10x and negative 9x. So I'm going to highlight that just so y'all know what I'm doing here. So I basically rewrote it like that. So now we're going to factor by grouping. So remember, you're going to factor the first two terms and the second two terms. So what do these two terms have in common? Well, they have a 2 and an x. So 2x times what gives me 6x cubed? 3x. 2x times what gives me 10x, and I'm going to say 5. So remember, you have to have this same thing on the other one, and if this never works out, your last resort is quadratic formula. So if you go to do this and it just don't work out, that means you need to do the quadratic formula. So these two both have a negative in common, so I'm going to factor that out. And then what could I multiply to 3 to get to 9? If you said 3, you are correct. Now, you need to make sure that this works as well. So 3 times 5 does give us 15. So here is your factor. So you have 2x minus 3 times 3x plus 5. So remember, these two become one factor, and then that becomes the other factor. That's why that has to be the same. So yes, we just did all that work for this numerator. But, I mean, it had to be done. Oh, I forgot the parentheses there. Oh, that looks ugly. Let me fix that. Sorry. So minus 3, and then 3x plus 5. And then we have nothing to factor there, so that one was easy for us. And then this 3x squared plus 5x, they both have an x in common. So I could factor out the x, and that would leave me with 3x plus 5. All right, not too bad. So now we need to multiply and divide out the common factor. So we multiply anything by 1, it just becomes that. So we have 2x minus 3, 3x plus 5, and that is all over 4x squared times x is going to give us 4x cubed, and then times 3x plus 5. All right, so we can see that these two factors are the same, so we are able to divide those out. And what are we left with? So we're left with 2x minus 3 over 4x cubed. And so now we need to find the whole. So, sorry if you couldn't see that. So we need to know, besides like right now, we know our asymptote is 0, because if we plugged in a 0 for x, 4 times 0 would give us 0. So we know our asymptote is 0. However, there are other places that may give us a hole in the graph that if you graphed it in Desmos, it doesn't give you the holes. So just like on the former ones, remember where sometimes we excluded numbers? That is what I'm talking about. So for example, in example 4, like when we excluded these, this meant that The graph doesn't exist at each one of those values, but if we were to graph it, it looks like it exists. So how do we figure that out? Like, how do we come up with that value? So essentially, this denominator is the same here, so we don't have to worry about that one. What we have to worry about is what could x be to make this 0? So if we look at 3x plus 5, so if we set 3x plus 5 equal to 0, because we still factored out an x, and that x is included here. So the only thing that is left is x, what was in here. All right, because these two became here. And so we subtract 5 from both sides, we get 3x equals -5. Divide both sides by 3, we get -5/3. So, whoa, that was a little aggressive. Sorry, I would have paused it, but I didn't think it would be that long. All right, so x cannot be -5/3. And so guys, if you need to talk about these, we can. I want to make sure that you guys have a good understanding. So again, if you want to talk about these, please come talk to me when you're ready to do this practice. All right, I'm going to end the video there. I'll see you in class.